Good evening. This is my lab report on lab number 1, charge tapes. The purpose of this experiment was to determine the excess charge on a piece of tape that has been charged. This was done by preparing 2 pieces of clear tape. We conducted trials in which different objects of various charges interacted with this tape. We observed and recorded those interactions, and using those records, we were able to calculate and determine the excess charge and the number of electrons transferred. We found in this experiment that the charged tapes repelled each other, but when in the presence of either a neutral or negatively charged object, which in this case was a plastic pen, the tape was attracted to that object. This indicated that the tape had a positive charge. We found that the charge on each piece of tape was 1.63 repeating, then times 10 to the negative 8th coulombs. We found that there was a total deficiency of electrons of 1.02083 times 10 to the 11th electrons, and per atom we found that the amount of electrons lost was 2.48856 times 10 to the negative 6th. Some of the models and principles that we used in this experiment was that like charges repel and opposite charges attract. We also used Coulomb's law, gravitational force, and Newton's second law in this experiment. Regarding Coulomb's law, the variable k is also represented by 1 over 4 pi epsilon, which is a constant. Some of the assumptions we made were that forces due to gravity and electricity are the only significant forces acting on tape B in the y direction. Air resistance was considered negligible in this experiment. We also assumed that charges are distributed uniformly on the surface of the tape. The pieces of tape equal in length and were equal in charge. The atom's area was equal to the atom length squared. And the space between atoms was considered to be negligible. Now, the primary experiment, which is the suspension of a piece of tape and the force of a different piece of tape acting on it, was conducted as such. We cut a piece of tape to a length of 20 centimeters. We folded one end of it, making a nonstick handle. Then using 2 different objects, we suspended tape B so that there was some slack so that it can be repelled. Step 4, we held a tape A, a charged U tape, under the suspended tape. In step 5, we would move tape A closer to tape B until tape B began to float. At that point, we carefully measured the distance between the 2 pieces of tape. Some of the known conditions that we used was 9E9, which is the constant k, or 1 over 4 pi epsilon, the charge, which is 1.6 times 10 to the negative 19th. We measured the tape length, the width, the mass of the tape was calculated, the distance between the 2 were recorded in step 5, and the area of an atom was found to be 10 times 10 to the negative 20th. This is the code that was programmed on GlowScript in the model, which is shown on the right, and the model, which is shown on the left. Our known variables that were outlined in the previous slide are shown at the top of the script. We were able to calculate the force due to electricity and the force of gravity using the principle of Newton's second law. From here, we were able to model the different point charges, calculated the electric charge from there, the total number of atoms on the surface of the tape B, the efficient electron to atoms ratio, which is the efficient electrons per atom, and then from there, we were able to calculate the total amount of the efficient atoms. When inquired by the what-if questions, we were able to conclude a few expectations. When 2 pieces of charged tape are introduced to each other, since they were charged using the same method, we can expect that they will have a similar charge and therefore repel each other. If a plastic pen that has been rubbed with carpet or hair can be assumed to have a negative charge, we can expect the charged tape to be attracted to the pen. If the tape was to be negatively charged, it would repel when near the pen. Because the charge is negative on the pen, we can expect the charged tape to be a positive charge if they are attracted to each other. Because a charge can induce a dipole upon a neutral object, it can be expected that a neutrally charged tape will be attracted to a negatively charged pen. If tape B is the system and tape A is the surrounding environment, and the moment of tape B is unchanging, it can be concluded that the net y component of the force on tape B is equal to 0. Tape A exerts mainly a vertical force on the floating portion of tape B. In order to determine the gravitational force on tape B, you need the acceleration in mass. The acceleration due to gravity on Earth is negative 9.8 meters per second squared, and the mass was calculated to be 0.0002 kilograms. And the free body of tape B when floating is shown below. Some similarities and differences observed between the computational experiment and the real experiment is that on tape B, following Newton's third law, the force of gravity and the force due to electricity are opposite in direction but equal in magnitude for both experiments. Also in both experiments, due to Coulomb's law, the force for electric force and charge are calculated in a similar manner. The differences we found is that in the GlowScript code, due to the assumption that charge is uniform on the tape, the charge is modeled as a point, whereas the experiment did not visualize it as such. The magnitude of the force is also much smaller in the GlowScript model. Some possible sources of error in this experiment could be from 1, the measurements, which were taken freehand, so the length of the tape and the distance between the tape measured during the experiment could be minimally inaccurate. The charges naturally also get lost into the surrounding environment, as the experiment is not conducted in a vacuum, and as such could lead to some error. Also, because the experiment was not conducted in a vacuum, forces that were assumed to be negligible may have affected the experiment. Thank you.